Now, as we get started, let's make sure we're all on the same page here, and let's talk about understanding databases. Now, what exactly is a database? And there's a lot of different definitions out there, but the simplest and best one is that it's nothing more than an organized collection of data. Now, a lot of things count as a database if we use that definition. A stack of papers on your desk could be a database, and they would be. The phone book would be a database. But let's go a little further. A structured set of data held in a computer and accessible in various ways is really what most of us think about when we think about databases. Now, that structured data storage part is what makes the management of large sets of data both possible and efficient when we combine them with computer technologies. And by possible and efficient, we mean that we can very easily and efficiently add data, modify data, or delete data from that database without any danger of damaging any of the data around it. So what's the real advantage of databases for us? Well, first of all, structured data can be queried. The data can be searched very efficiently. The search results can be limited by very specific conditions that we can determine. The data in our database tables can be joined, compared, reordered, whatever we want to do with them. And relational databases, which is really what we're talking about most of the time when we're talking about databases in the modern world, contain multiple tables that are related. Now let's look at an example of that. If I jump out into the Microsoft SQL Server Management Studio, like you see here, and don't worry, I'm going to show you all of this later. You'll see how to open the Management Studio and get exactly where I'm at right now. But notice this database probably started out as, let's keep a list of our products. And so we gave it a product ID, a name, product number, color, a reorder point, a standard cost. And then over time, we added more and more descriptors or more properties of each of the pieces of data that's going to be stored in this table. Then over time, our database grew, and it got, as you can see here, slightly more complex until we have this many tables in our database, and the little lines here show you how these tables are all related to each other. Now, I'm using a functionality in SQL Server Management Studio called diagramming, and this is actually a database diagram, and I'll show you how to work with these a little bit later on in the course. But this is where our databases inevitably end up. Most databases are a lot like people. They start out small and relatively simple. Remember when you were a child? Well, you probably don't even remember, but if any of you have children, you've been around children, they start off very small, relatively simple. They scream, they cry, they eat, and they do some other things, and we'll leave that out here. But spreadsheets, Word documents, simple lists are the database equivalent to babies. They're very simple. We just got a little bit of information there. We're not trying to do a whole lot of work with it, but over time, that data continues to grow and grow and grow. And just like the little baby, it starts to get a little more complex. Different departments need it. They need to see it organized differently, compared differently. They need more and more information kept. And it's not too long before the spreadsheets, the Word documents, and all those become slow and inefficient. And they are also impossible to maintain. Because before you know it, there's 26 copies in 43 different places. Nobody knows whose the latest copy is. Nobody really understands which one's up to date or how to go about getting it up to date. So when we're talking about structured data in a database, this is really what it looks like. Now, this is what a database table looks like in a very simple form. Notice we have column names at the top, and then in each column, we put a piece of information. So this particular row, row 1, is about Harry Smith. Harry's 23 years of age. He works in the sales department, and he's a level 3 employee, whatever that means. But notice that we arrange our data, or we structure our data here in what's called records. So an entire row or a collection of columns is a complete record. So you can tell that all of these columns together makes a complete record or a complete thought or a sentence, if you will, about Angela James. We can tell her age, her department, her level. Now, the columns are what's called fields, but you got to watch this definition because Microsoft refers to columns as fields, but a database purist out there would snicker if he or she heard that, and they would tell you that a field is this individual piece of data, any one individual piece of data. And Microsoft will interchangeably use those terms, but just understand in the Microsoft world, usually field refers to a column, And record refers to an entire row of data or a complete set of data. So how much data are we talking about when we're talking about databases and structure and all that? Well, there was a time when we were working on products like Ashton Tate's DBase program way back in the late 90s, mid 90s, I guess. And if I had a 10 megabyte database, people would stop by my desk to see this massive 10 megabyte database. But if I were to call you nowadays and tell you that I had a 10 megabyte database, you would worry about me. So terabytes is what it takes nowadays to impress anybody with any kind of significant database structure. But keep in mind that if you have a database, let's go back to that little table that put up here just a couple of minutes ago and demonstrated the records in the fields. If that table was 1 terabyte in size and each individual row utilized 6,000 bytes, then we would have 183,251,937 rows or records in that table. So you can tell that storing the data efficiently and in a very tight, well thought out structure, and then using proper query techniques to query that data from that table or modify that data or delete that table is going to be vital to making this database useful to us. So that's what we're going to be about in this course. We're going to talk about how to use the Transact SQL language to write efficient queries to select, insert, update, and delete data from our database tables, and these tables will be related to each other. So we're going to cover a lot of ground here. I just want to make sure you understand what we're looking at, where we're headed. So now let's get busy.